We got worms. That's a Dumb and Dumber reference. If you're not of a certain generation, you won't get it, but that's okay. Let's face it, internal parasites, or worms as they're called, in sheep and goats are a giant drag on production and on mortality rates. And we just don't have a decent way or an easy way, a chute-side way, to actually measure genetic resistance in sheep and goats. Why is that? That's what I wanted to find out. So I went digging and I got to sit down with Dr. Scott Bowdridge of University of West Virginia to talk about where we're at with genetic selection for parasite resistance and what tools actually are available or coming down the pike. All right, I'm Lyndsey Smith with RealAgriculture. Joining me, Dr. Scott Bowdridge, Professor of Animal Science with West Virginia University. Scott, we are going to talk about parasite resistance in sheep, or perhaps the lack thereof. Welcome here. Tell me a bit about your research that you do, what keeps you busy at West Virginia University.
So thanks for having me, number one. Number two, what keeps me busy here is kind of the question that I started my career with, was trying to understand the basis or the mechanism of parasite resistance in sheep. So in the southeastern United States, it's been a plague for decades. It's really affected sheep production. I was raising sheep in Maine when I started graduate school, and we're even dealing with problems there. So I got involved in a Katahdin upgrade project back in the early 2000s, and that led me to my career path where we really worked to study the immunological mechanism of parasite resistance in one of the progenitors of Katahdin sheep, which is the St. Croix. So we use the St. Croix as a model of kind of full host protective immunity against parasites. And then we used a very classic terminal sire in the US, which is the Suffolk, as our kind of susceptible model. They're cheap and easy to find, and really like to find ways to kill themselves. So that's kind of where we got on, and then kind of have migrated more back to some more Katahdin work recently.
So, and as background sort of for this conversation and why we're having this as well is that, parasites for sheep, it is for Canada and the US, it's a giant issue. It is a production loss, it is a death loss issue for sure. And it does beg the question as to, do we have genetic resistance out there? And then the next part to me is, how do we test for it? How do we bring it into our sheep flock? So I guess let's start there. What do we know as far as assessing the genetic potential of resistance within? And if we have to keep it to Katahdins, we'll leave it there. But what is the potential really of what we have in genetic resistance?
So we can take more of a geneticist viewpoint and say that the genes exist, right? In all the populations, and whether or not you can identify those animals that possess those genes are the question. So I use an example from Maine. We were using some Suffolk ewes to upgrade Katahdin sheep, and there is a Suffolk ewe out there that we've never dewormed. So you don't recognize her. She doesn't stand out. She's not, but she's the ewe that you never deworm, right? And I think that all of us at some level have, I call them unicorns. They're just the sheep out there that never show up on your radar. They're not particularly interesting. They just do their job,
Mm-hmm.
and they have their babies. They're fairly disease resistant, but we never tend to identify those animals and really amplify those genetics. So they exist. They exist within wool breeds. We've just never harnessed any kind of selection pressure on those traits, and have really focused on things that you're getting paid for, right? So you're getting paid for pounds, whether that's pounds on the hoof or pounds shorn. So that's been the emphasis of sheep production in North America for, I don't know how long. I mean, for as long as sheep have been here, right? I think more recently we've discovered the fact that, hey, we're losing some lambs, and then it was a perfect example. There's a producer in South Dakota that called me. She lost 200 lambs in 1 month, and that was after a treatment with valbazin.
Yeah.
So after they had gotten the treatment of albendazole, they were grazing irrigated pastures, grazing irrigated alfalfa in South Dakota, and she lost 200 lambs in a month after the deworming. So it's not a problem just in the southeastern United States anymore. It's migrated north, it's migrated west, and it is starting to impinge on some of these other production systems. I'm from the desert of Southern California, where we used to have a lot of kind of nomadic range sheep that would be grazed through federal land. They don't have much of a parasite problem. So you kind of have this balance of some locales across the U.S. and in Canada are going to experience more parasite pressure. Some aren't. It depends on the grazing system, how intensive that grazing system is, and a lot of it has to do with climate and how many warm months do you have, and what's the value of the or the nutritional value of some of the forages that they're grazing. So there's a lot of things that impact this, and it's not quite as simple as we want to make it out to be sometimes.
Yes, and definitely even here in Canada, where we get winter for far too many months of the year, we still have very hot, humid summers. And so it even with that, very cold break, it doesn't really matter with a hot and humid summer.
It doesn't, and I think there's kind of a myth that the freeze kills larvae. And yeah, it does. It kills a good proportion of them. But I tell this story pretty frequently. I got some larvae from another professor down in Louisiana. He froze them to minus 80 degrees Celsius, shipped them to me. They thawed out. They were still moving.
Hmm.
So a minus 80 freeze thaw, they were still moving. I put them in my minus 80 freezer, pulled them out, not as many of them, but some of them were still moving.
Mm,
So not only are they surviving the winter, they're also overwintering in the host,
right.
which is that hypobiotic effect. And I think we're all guilty of this. We relied on drugs for way too long and to manage this problem for us, and we forgot how to find immunologically fit livestock, whether that be cattle, sheep. It doesn't really matter. We have really we're all guilty of this. I'm just as guilty as everybody else. I love a needle and a syringe and a solution to the problem. We've relied on it for far too long, and now we're dealing with some of the consequences of the parasites developing resistance to every drug class that we have
Yeah.
available in North America.
So on that note, though, and this is something that as a producer myself, we also come across, though, is that I do feel at times sometimes we hear that like, don't depend on the dewormer because, we have resistance and those sorts of things. Then we hear that as don't ever use them. And we think that we can manage our way out of a problem. So how do we balance that the use of effective products, if they're still effective, with the
Right.
integrated management? Because to me, if we ever say it's only one, I think we run into trouble.
I agree with you 100%. So my philosophy is less about drugs are a tool, right? And in all of this, it's really thinking about the effective use of the drugs. So we were all trained through university systems is that you rotate your dewormers because you're going to keep the worms on their toes and they're never going to guess what you're going to choose next. You only had three options,
Right. Yeah.
realistically, right? So there wasn't really that much to guess. What ended up happening is that slowly but surely we developed this population of resistant parasites. Does that mean that we just stop using drugs in general? Absolutely not. We have to think about how we use drugs more judiciously and use them when they're going to be the most effective. And then get the thought out of our minds that a sheep flock, a cattle flock, or a cattle herd are going to be completely sterile of parasites.
Right.
It's okay to have some worms, right? There's some sheep that can manage that without it impinging on production. But I don't need sheep carrying 8,000 adult worms and then, oh, we're going to move to a different field or we're going to change nutrition and you just end those animals. So I think that we can use the FAMACHA scoring system as a way to think about that judicious use of anthelmintics or dewormers. We can look at DAG scores. We can look at diarrhea, use the 5-point system that they developed in Canada as a way to selectively deworm animals to maintain efficacy. Now, I had conversations with guys in Australia. He said, you guys in America are crazy with trying to FAMACHA score everything. And he's absolutely true. You're running 30,000 ewes.
Yeah.
If you do 1,000 sheep a day, you're going to have to do that every day of every month during the grazing season. Right. It's impossible. He also was working at a farm where they had multi-drug resistance. So what do you do in that case where you have no drugs that work? The producer that he was working with gave him 1,000 ewes to work with. And he said, you know what we found is that we went from having a fecal egg count reduction of 20%, right? We're only killing 20 or reducing the egg count by 20%, all the way up to 70% in 8 years just by using FAMACHA. So by using selective deworming, we can regain some of that efficacy of the drugs back, but it's not. There's not a single solution to this.
No. And you also, so we've got, to point these out, we've got FAMACHA scoring, which is an indication of anemia. We've got DAG scoring. We've got fecal egg counts, but not all worms, and especially something like the worst one, like barber pole or homuncus, it doesn't cause DAGs. It doesn't necessarily cause diarrhea. So,
correct.
So when we're talking about parasite resistance, are we largely focused on the homuncus, on the barber pole problem, and the other ones sort of follow suit, or do we need to think about them as different internal parasites and manage them all differently?
Kind of going to keep a simplistic approach to this. I cannot differentiate on a fecal egg count a homuncus egg from a Trichostrongylus or Telar drossagia or any. I'm sorry, I'm using all of the.
Nope, we love those words.
Redneck worm, bankrupt worm,
yeah.
Right? All of those. I can't differentiate those eggs.
No.
Effectively and at a speed in which makes it useful for doing fecal egg counts. So I'm just going to say that I have a lower strongylid egg count. And I know, like where we're at in West Virginia, kind of the mid-Atlantic portion of the East Coast, we get a lot more Trichostrongylus and Telar drossagia in the early part of the year. So they tend to be cooler weather parasites, where homuncus comes in when it's super hot, right? When it's hot, warm, moist, that's when we get more homuncus, and we'll see more of that once we start speciating those eggs out. So you actually have to develop the egg into larvae and then kill all the worms and then stain them and measure how long they're from their sheath to the end of their tail. And even then, even the parasitologist, which I am not, by no means am I a parasitologist, but the parasitologist will say it is really hard to differentiate even some of the larvae within this kind of complex of trichostrongylid parasites. It's hard to pull them apart. So I think that I'm going to use Dr. Zajac was one of my mentors at Virginia Tech. She wrote, did a lot of work with this, with homuncus and sheep, and working with producers and academics across the globe on this. But her thought process was, let's worry about the worst one, and that's homuncus. So that's where my thought process goes.
Mm-hmm. I agree. Not that it matters, but if the really smart people think that, I'm on board. And honestly, I mean, we can think about production losses, but ultimately the biggest losses are the deaths that happen seemingly instantly, overnight, etc. And that's going to be something like homuncus. That's usually what's going to get us. So I agree. Let's focus on the worst one. So then we take this too. So as you said, now we could do a whole other conversation, of course, on pasture management, on all those things, and not to say that that's not important, because it's incredibly important. But I want to stick with the genetic side and the testing side. Right now, as far as I understand it, in North America, so Canada, US, whatever, we do not have. Am I right or wrong here that we don't actually have like a hair test or a blood test that could tell me this animal is resistant?
Yeah, so with this particular disease and with parasite resistance, it's not just one gene. So it's not like when you're dealing with scrapie, for example, and you're looking at a scrapie genotype and you send a blood test out and aha, you've got 2 copies of arginine at codon 171. Fantastic. You
Yeah.
are less susceptible to scrapie. We don't have that for this trait that is controlled by a multitude of different genes. So there is no at this point, and so all of us have tried, and I think every faculty member who's gone into this research area starts with the idea, I'm going to be the one that's going to find the major gene of interest, right?
Right.
So when I started my career at West Virginia 15 years ago, that was our thrust. And we had the best opportunity of anybody because we have these really resistant St. Croix sheep that actually clear worms by themselves.
Right.
On the first time they're exposed, they clear it by themselves. We had a great opportunity to find that. We didn't. I mean, it doesn't matter what you do. We even deal with new faculty that are coming on now, and I'm kind of the old curmudgeon. And I was like, we've tried all of that stuff. I don't know what you're going to find. So I sound like the old guys now, but I still say go after it and see what you can find. Nobody's landed on that one thing that says, aha, this is it. This is what we can test for and go with it.
Okay.
It's not easy.
Yeah, it is not. And I really was hoping, but I was like, if it was easy, we would have got there by now. So then the next step is, because on the discussions of, so things like FAMACHA score, DAGs, fecal egg counts, so for example, on my own farm, we are evaluating our ram lambs on which ones we would select back for breeding. If we went strictly on like phenotype, there's all sorts of fallout from that, right? We could be overly selecting for singles. We could be selecting for the earliest born. We could whatever. But we could put a DAG score in there. We could all those sorts of things. But if I'm evaluating ram lambs, let's say, and they are on pasture, so they were with their mother, so they should have been challenged in some way, is a point in time fecal egg score, like one time, let's say, of a portion of them, is that going to be enough to make a decision on, or would I have to do it a couple times? Do I have to compare it against other flocks? Like, how do I know if that's enough?
There's no really great way of doing it. And that's why I was telling you earlier, I would have loved to have been a fly on the wall when they were having this discussion. So you have to think about the guys that were doing this. It was Dave Notter from Virginia Tech, who's just a wonderful geneticist, Dr. Parker from Ohio State, Dr. Zajac from Virginia Tech. These people met, in the early 2000s at a USDA facility, actually in West Virginia. And from what I've been told, it was a knockdown, drag out, people screaming at each other fight about, do you do it at 8 weeks of age or you do it at 16 weeks of age? Right. And what's going to be predictive for lifetime parasite resistance? And, I think that Dr. Parker's version was, hey, we do it at 8 weeks, we get a a weaning fecal egg count.
Right.
And that's going to be most informative. And then Dr. Notter would say, well, what about January born lambs in the northern hemisphere?
Yeah.
They may not be challenged. So let's move it to 16 weeks, right? So what they finally ended up on, and what we utilize in our own genetic evaluation in the US, is a weaning fecal egg count. So that's anywhere, whenever you wean your animals, you can do that. And then we have a post-weaning fecal egg count. Now, with that submission standard, we have early post-weaning, late post-weaning, but there's nothing else attached to it. There's no weight, there's no age. As long as they are after weaning, they could be hoggets. I mean, they could be yearlings by that point. So you don't really know, but what I base my research on and kind of the stuff that we do is more people are likely to collect an accurate fecal egg count at the post-weaning time, just because of when sheep are lambing, when they're going to be exposed to parasites, and it's going to cover a broader swath of the continental United States in collecting those data. So in your situation as a commercial producer, when's the best time? So I'm going to ask you a question: is when are your animals most infected? When are their fecal A
Right.
counts likely to be the highest?
Yeah.
Right?
Probably just post wean based on
Okay.
when they're born, right? So that lines up pretty
Right? So
well.
you can
Yeah.
take a post-weaning one. The
Yeah.
great thing that we know is that there's a fantastic genetic correlation between post-weaning and weaning fecal A counts.
Yeah.
So they're positively correlated.
Okay.
If you
Yep.
have high weaning fecal A counts, you have high post-weaning
Post.
fecal A
Yeah.
counts. Right?
Yeah.
Here's the problem with fecal A count. What does a zero mean?
Yes. Right? So
Right?
this is why there's the next question is that let's say I test everybody and I mean amazing zeros would be amazing. I don't think that would happen based on our situation, but like let's say everybody has the same. What does that tell me? What if I have zeros? Does it just mean
Well,
I just haven't I just there I'm in the wrong stage of of the work? Like
so
what does it
what
tell
we
me?
do in our genetic evaluation system is we kind of set this arbitrary threshold. And working with Lamb Plan in Australia, who helps calculate our breeding values in the US, they have come up with the fact that, all right, if you submit your data for this, you have to have a flock average fecal A count of 500. So
Right.
you know that there's some exposure that's
Right.
there, right?
Yeah.
But here's the weird thing about this. So we calculate our breeding value based on percent reduction relative to the contemporary group average.
Hmm.
So to put that in plain English, if the contemporary group average is 500 and you're at a zero, zero minus 500 divided by 500 is negative 100,
Right.
right?
Yep.
Is that one parasite resistant?
Maybe.
Okay, so let me throw the other one. We'll take a flock in Georgia, for example, that has an average fecal A count of 5,000
Hmm.
and an animal has a zero and they're still negative 100.
I
Which
would
one's more parasite resistant?
Yeah, I'd rather take
Or are
that
they
one.
the
Yeah.
same?
Or are they the
So,
same? Yeah.
right. So these are some things that we don't really have a great handle on. All we know is that for right now, it's kind of the best measure that we have. And we have done some of the experiments. So, apologies for using hair sheep.
Hmm.
I grew up raising Rambouillet sheep in Southern
Mm,
California.
yep.
So my roots go back to kind of those classic Western range sheep. Um, but I was able to take Katahdin sheep and divergently mate them for fecal A count. So I had parasite susceptible Katahdins
Hmm.
and parasite resistant Katahdins. I know that when you select for it, you get it,
Right.
right? When you select for parasite resistance, you bring down the fecal A count of those sheep, and it happens every single time. It's repeatable. It's not highly heritable. It's kind of a
Right.
low heritability trait that we've had to experience some adjustments on in the last few years. Dr. Notter's first estimate of heritability was probably a little like overestimated
Mm,
heritability for the
okay.
trait.
Yep.
Once we adjusted that back down, so we had a large USDA project that analyzed like 7,000 sheep across the U.S. and we're able to adjust probably right size the heritability for the trait relative to the U.S. sheep flock. So,
Okay.
and we do have this trait for Rambouillet sheep in the U.S. if you submit data. We
Okay.
have this for polypay sheep in the U.S. if you submit data. We have it for Suffolk, for Dorsets. It's available for our more traditional wool breeds, but I haven't found a Montana producer who is going to submit fecal A counts on
Right.
lambs because they're not going up to their summer pastures to handle
Yeah.
sheep,
Yeah.
right? So that's not going to happen. So
Yeah.
it's a real challenge on how do you open up the door for parasite resistance in some of the kind of the Western range production systems.
Right. And that is really where it comes sort of full circle to how I sort of got down this rabbit hole of calling you up
Yeah,
was that, at a commercial scale, like if we lambed, in a barn or in a yard or whatever and we had 50 sheep, pulling fecal egg counts on a couple sheep is not that difficult. But
not a big deal.
our sheep spend their entire life on pasture, grass, or in a field. They
Yep.
don't come into a building except for shearing day. And so it's not impossible, but it is a much larger undertaking. And imagine if we were at 1,000 ewes or at 2,000 lambs that we're trying to select for. You sort of have to make your selection before and sort of right, and then only of those that you've already selected on other premise do you then test them. And then I guess if nobody's resistant, and I shouldn't say nobody, but if everybody scores super high, maybe you have to go back to the drawing board. I don't know.
Well,
So
so
yeah,
you could have animals that are very high. Remember that everything's relative to the contemporary group average. So
right.
what that
Yeah.
average is.
Yeah.
So if you have a high average to start with, you may not have a propensity of animals with zeros or 100s. The other thing you have to remember is that 1,000 eggs per gram is 20 eggs on a slide,
Yeah.
right?
Yep. Yep.
So what are we getting all wound up about, right? So my threshold for I don't recommend deworming based on fecal egg count because it's too much handling.
Right.
It's way too much handling. And the turnaround time, like I'm pretty good at doing fecal egg counts. I can do 10 an hour by myself,
Right. That's only
right?
10. That's
That's
10.
only 10,
Yeah.
right? So if
Yeah.
I have 100 sheep, that's going to take me 10 hours
Yeah.
nonstop of doing fecal egg counts. And it's kind of a pain. My lab, we have a very efficient system of doing that. I have the student labor to do all this stuff. So we can do a couple hundred in an hour. It's not a big
Yeah.
deal for us to do that. That's why we do so many. Um, so I don't recommend that for people to do. So in
Yeah.
your case, we're talking about selecting, ram lambs to be replacement rams for your breeding program. It's just identifying of this group of ram lambs that are
Yeah.
acceptable for every other trait that you are getting paid for.
Yeah.
Who's the sneaky little turd in there that
Yeah.
is going to be your parasite resistant, good growth, good wool quality ram lamb that's there?
Yeah.
And you don't need, I assume you need more than one.
Mm-hmm.
And that's
And
the challenge.
yeah, that's the challenge, right? Is that ultimately, for even a flock our size, which we are not, a large flock by any measure, let's say 500 ewes. I mean, but we would like to hold back 20, let's say, to start with, and sort of, right? And so, because we have other rams too, but like that's just annually, we'd like that many. It probably means that then you are evaluating more than that because you're going to have to kick some of them out. So, yeah, and so I am both encouraged that I'm not the only one who's sort of come up against this and said this has to be sort of like chute-side available before it's really going to catch on large scale. But we do have
That's
at
right.
least some tools.
Right. So you have the saliva test that is out
Yeah,
there. So that'll give you an idea of some animals' resistance. But here's the gamble with that. They have to have had an infection.
right. Yep.
And in most, so big caveat, most wool breeds and getting those animals through that, are you willing to sacrifice exposure for that?
Right.
The gold standard of this is being able to identify resistant sheep before they've become infected,
Right. Yeah.
and that is the that's kind of the brass ring of figuring out all of this stuff. And I'll kind of give you a story, if you don't mind,
I don't.
about some of the work that we're doing now that might lead us down that road. So when we started this divergent mating project at Virginia, the guy who ran the farm thought that we were just going to bury all of the positive lambs. So if they
Mm,
were, I mean, we were using rams that were plus 600. So that means that they were
wow.
600% above average
Right.
in their breeding value for this trait. So, and all we did was we took rams, we took three very parasite resistant cotyledons, three very parasite susceptible cotyledons with really high accuracy for their predictions, and mated them to 150 ewes. The lambs that came off those rams that year, so we had a Clostridium A outbreak
Mm-hmm.
in this area of Virginia that we were doing this research project at. So the lambs that were sired by rams with low fecal egg count breeding values had a 10% death loss. The lambs that were sired by high fecal A count or more parasite susceptible rams had a 30% death loss.
Hmm.
Was not parasite derived, was
No.
not predator derived, was 7 days post birth and 2 weeks to 2 weeks post weaning. So if you think about that for just a
Mm-hmm.
second, in a really dirty environment where you've got this pathogen that's out there, when you select for parasite resistance, what else are you selecting for?
Yeah. Immunity,
Disease
really.
resistance,
Yeah,
immunity,
exactly.
right?
Yeah.
Okay. So then we said, all right, let's go back. If parasite resistant sheep are just have a better generalized immune response, what's an easy way to measure that? Let's look at their antibody response to vaccination,
Hmm.
right? And just
Yep.
a Clostridium type C and D
Yep.
vaccine. Parasite resistant sheep develop a massive amount of antibody to that vaccine during the booster compared to the parasite susceptible animals. So the resistant ones build a lot of immunity. Then I had a graduate student that said, let's think about colostrum production in ewes. Parasite resistant ewes had 2.5 times more antibody in their colostrum
Okay.
than the susceptible ewes. So we were to the point where let's just select for fecal A count. Everything's great. We can do this across all the breeds in the United States. I'll even give people worms to infect their sheep with, and we'll get data so we can handle the Intermountain West and the Western guys and the Texans. We can handle all of that. And then we started going back and like, these people are never going to do this. They're never going to get fecal A
Yeah.
counts, right? So I went back to my students' data, looked at this. We started collecting blood samples 1 week after a booster vaccination with CD&T, right? So we started a project a few years ago, well, a couple years ago at a producer's place up in northern Michigan, collecting. So last year, what we did is we took these 350 polypay lambs. We did a kind of an antibody phenotype on them for how much antibody they produced to a vaccine, to a booster vaccination. We did that 1 week after the booster, took the antibody samples, brought them back to school, measured everybody, picked the 30 lowest antibody lambs and the 30 highest antibody lambs, right? The high antibody lambs had an average fecal A count after we infected them. So we intentionally gave them worms.
Mm-hmm.
They'd really not seen that, they really didn't have that much of an infection to start with. It's real low. I think our average was like 100 eggs per gram. They were at 900 5 weeks after the infection. The low antibody group was 1900.
Mm.
So by the antibody response just by itself,
Yep.
which is a one time, you take a blood sample 1 week after you booster everybody, we could predict who was going to be more parasite resistant on that. So right now we have a project where we're collecting 10,000 phenotypes across the United States. We got Rambolays, Targies, Polypays, of course, Katahdins, and some Suffolks thrown in there to make sure that we're covering everybody to analyze this. So we're spending a lot of time in the Intermountain West and out in Montana. We're headed back to South Dakota, Minnesota, Iowa this fall to collect more of that as a breeding value for disease resistance,
Mm-hmm.
for reduced death loss, as an ability for some of these producers to select for this without getting fecal A counts. Because
Right.
fecal A
So
counts are a little messy.
they are. They're a lot of work. Anyone who's done them knows that they
Yes.
exactly that. You're really good at it, and you can do, 10 an hour. Imagine someone who's trying to do it, and then you have to have the equipment. Now, that being said, they are also not that complicated. That they are,
They're not.
they're not. So if you're interested in doing it, the average person can do it with a little training. But at the same time, it's time consuming, and yeah. So that gives me hope, though, that we are not necessarily directly measuring resistance to parasites, but we are measuring a very real thing for disease resistance or higher immunity, and it
That's right.
correlates to parasite resistance, which gets us closer to a blood test that would actually maybe.
So is parasite? So this is a question that's been floating around in my head.
Okay.
When we look at fecal A counts,
Hmm.
how much of that is behavior and how much of that is true immunity,
Right.
right? So you
Yeah.
can have some animals that are more selective about their grazing, and maybe they learn that from mom, and there's we can hypothesize a million different scenarios with this, but there's some behaviors that we observe in animals where they don't graze in areas where there's a lot of infection.
Right.
And the nice thing, I think, with the antibody stuff, so when we look at really parasite resistant sheep, their antibody variation is huge. So I could have very parasite resistant sheep that don't generate a lot of antibody. And I have very parasite resistant sheep that generate a ton of antibody. What happens with this is we kind of get these four quadrants. We
Right.
get the high antibody, really low fecal egg count breeding values. We also get low antibody, really low fecal egg count
Mm-hmm.
breeding values.
Oh, you froze. Are you there?
Project.
Oh, there we
Yeah,
go.
I'm here.
Sorry, I lost you for a second. You froze for a minute. Okay, back to the quadrants. So we get high and high, low and low, and the mix of in between each of those.
That's right.
Yeah. So it's not perfect, but well, this is why researchers still have jobs and extension staff.
Well, so at the same time, it might tell us that behavior is
It
playing a
does play a
role.
role. Yeah.
And that selection for the antibody side may be a better tool for
Right.
this
Longer
because it
term.
will
Yeah.
get rid of the behavior that is affecting the fecal egg count. And
Right.
some of that behavior is not necessarily inherited.
Right. Or it could very well be learned, right? We use the
It could be
example
learned.
if we use the example of fence jumpers or fence crashers. We have because we're fully
Mhm.
grass based, an animal that doesn't stay in a fence does not stay. But we use our fences to keep them in moving so that they're not going back. Well, something that jumps a fence and keeps going back to, let's say, a dirty field might end up with higher egg counts because of behavior, not because of necessarily an immune response, right? So,
That's
yeah,
correct.
yeah, okay. That is, I hadn't really thought about that either, um, which further complicates everything. But
Yes.
okay, let's leave it there for now. There is so much more on this, but that is, I think, a really good snapshot of sort of where we're at and what's to come, which is super exciting. And I've learned a lot here, so I hope other people listening have as well. So Scott, thank you so much for joining me here. This has been fantastic. And we will be in touch because I have more questions, and we'll just have to do that in a different interview.
Sounds good.
Thanks to Scott for joining me for that lengthy conversation. If you've got questions about this or thoughts or have an idea of how you're managing parasites on your farm as far as selection goes, would love to hear about it. You can zip me an email, lsmith@realagriculture.com, or reach out across social media. Would love to connect. And thanks again to Scott for making time for me. We'll be following up on this again, I promise you.
For the latest ag news, agronomic advice, and more, check out realagriculture.com and Real Ag Radio.